Hi, welcome to another edition of Antique Radio Archaeology. Today I'd like to continue the series on test equipment with a part 2 to the WV77E vacuum tube voltmeter restoration. Now, where I left off on the last video, I pretty much finished the restoration and did all my preliminary testing. And what I'd like to do at this point is I'd like to make a modification to it. The problem with these vacuum tube voltmeters is in order to use the ohm scale you need 1.5 volts. Now to do that they put a battery and a battery holder inside. Now I got really lucky with this one because the battery, even though it was an original battery, that dang thing did not leak. And it still had 1.2 volts on it. That is highly unusual. Usually those things leak and make a big mess inside. Now I did put a new battery in it, so it's probably good for a while, but I really don't trust it. I'd really rather just get rid of the battery, and we're going to just go ahead and put in a solid state regulated power supply for 1.5 volts. And the way I did that is I went to eBay and picked up this little battery eliminator. Now this is for a Heathkit model IM28, 13 or 5228. It works in any one of those. And they send you these neat little set of instructions that tell you exactly how to put it into that voltmeter, which isn't going to do me any good. But the concept's still the same. I'm going to tie one lead to the 6.3 volt filament voltage. This is going to rectify and regulate the voltage down to 1.5 volts, and I'm going to go ahead and hook those wires up to where the battery should go. So very simple. The other thing I'd like to do is I need to make a probe for it, because the DC probe, in order to avoid the capacitive nature of the probe, needs a 1 meg resistor right at the tip of the probe. So I'm going to build a probe with a 1 meg resistor in it for the DC portion. And the other thing I would like to do on this thing is go ahead and do a complete alignment once I get all these modifications done, so I can walk you through the alignment procedure, which is actually very simple. So let's go ahead and tear this thing apart and get the battery eliminator installed, and we'll go from there. Okay, I'm going to explain very quickly what I'm doing here. This is this battery eliminator right here. I got 6.3 volts coming into a diode, which is actually under this shrink wrap right here. And I've got this little capacitor right here, which is probably going to take down some of the ripple on the rectified voltage coming out of that diode. Goes into these screw terminals, and then I'm going to hit my C1, which is down here. This is that little tiny micro component, and it's probably going to get rid of a little more ripple, and then it hits my pin 3 on my LM317 regulator. The regulator itself has a little control arm here that's attached to R2, which is this variable resistor, which has a wiper arm tied to the negative or ground potential, and that in conjunction with R1, which is this other little micro component here, is going to drop that voltage down to my 1.5 volts. It gives me an adjustment that allows me to get it there. And then it's going to hit this other electrolytic capacitor, which is probably going to take down a little more ripple and get that thing out as 1.5 volt clean DC voltage. Now, the nice thing about this, the reason I don't have any component values on here is I don't want to, sabotage this guy's little eBay business. This thing's very inexpensive, 13 bucks plus shipping. You can't beat it. Go to eBay, buy one. Don't try to buy all these components. You'll spend more than that just on components. And that board itself is small, plus it allows you to use those small components in it, giving you the ability to put this right in where the old battery was. Has some standoffs, so I may have to drill some holes in the board if I have the place where I can do that, and that will really help set things in there. Now, because this was designed for the Heath kit, I have to figure out where to put it in this as far as tying into the circuitry. So the old battery is this BA1 here, and it's going to that half amp fuse. So I know right now that's where I can tie my positive. The negative can go to the negative of the battery, so I've got those two connections here taken care of. Now my other issue is, where do I tie the 6.3 volt line? Now what I've got is the 6AL5. This identifies pin 4 and 6 as the heater voltage. What I don't want to do is I don't want to tie this to the ground side of it. I want to tie it to the other side, so I may have to go to pin 4. But we'll see once I get this thing apart and can do a voltage check on it, and then we'll go from there. Okay, so here's the battery. And there's my fuse. Wow, pin 1, 2, 3, 4, and 5. Pin 1 and 5 are together. So what I'm going to have to look at is I'm going to have to fire this thing up and see if pin 4 actually has the 6.3 volts on it. Which that will solve this puzzle once and for all. Pinout of a 6AL5 has 3 and 4 connected to heater. This one has 4 and 6 for some reason. Now, this wasn't making much sense, but then I finally think I figured it out here. What's going on is, if I pull this tube out, 1, 2, 3. Yep, 1, 2, 3. That would be 3. That's this pin right here. If I go to ohm scale, hit 3 and 4. Nope. 3 and 5. 3 and 6. Okay. So 3, 5, and 6 are all shorted together. And that actually kind of makes sense because 6 is not used as a pin, so it doesn't really matter. 5 is tied to the chassis ground. The 6 is tied to the chassis ground. So if you tie 3 to the chassis ground, that makes 4 the hot one. Okay, that makes sense. So 4 and 3, or 4 and 5, 4 and 6, any one of those pins will work, but 4 is the one I really want to tie to. And just to make sure, I'm going to go ahead and hook this up, make sure I've got 6.5 volts at least on pin 4. So I've got this thing, it's already turned on. I hate doing that, but the way I've got this positioned, I've got this thing sitting in the case like that. It's unplugged right now, by the way. So having that sit in the case, it's helping me to stabilize this. I might shorten things together. Okay, tube back in there. Now, with that being said, I can go ahead and plug this in. My isolation transformer, go to AC scale. I should be able to check with pin 3 and 5. 3 and 4. A little high. I'm reading 6.8 volts, but there's my AC. Okay, so 4 is definitely where I want to be. Okay, that tells me what I want to know. So I'm going to tie my yellow wire to pin 4 when I do this. Go ahead and turn that off. First things first, I need to get this stuff desoldered. Can go ahead and remove the bracket, so I will no longer need that. Okay. Alright, so let me board is that wide. Alright, so if I put the holes on this side of the board, I will be fine as long as far as the traces underneath, there's no traces. The traces, I'm clearing all the traces. Go ahead and drill 2 holes in that board. Alright, so I'll go ahead and so that's where my holes are going to go. Perfect. That'll work. Yes. Alright. Now I should be able to install the board. Gets my board in there. Now this is going to be my ground lug, so I need to get it over to here. This will be my positive. That needs to go to there. And this one is actually going to go underneath. I'm going to get it over to this pin 4 over here. Use that battery hole. Okay, that's where I want it to be. And this one needs to come over to this side, and I gotta catch that right there. Alright, there's my negative side. My positive, my negative. Now I need to do my pin 4 on this tube. Start by pulling the tube. Four is right there, which is that dot right there, where I need to get it. So we're all hooked up. Do some wire routing here. Ah, that's not going to work. It's got a diode in between. Oh yeah, well, forward bias. Yeah, so that's my pin 4. It's correct. Minus, plus, I know where they need to be. Alright, everything is installed. Now, what I need to do, I need to make sure I'm getting 1.5 volts out. The way I'm going to do that, I'm going to go between my ground between those 2 pins right there. I can adjust it right here. So, make sure the AC is on. AC volts. And I'm reading 1.55 volts. And that's fine. That's perfect. That is perfect. Okay. Got my volts. My battery is no longer an issue. So here's exactly what I did. I went ahead and put this battery eliminator, got rid of the battery, tied the plus 1.5 volts here, the minus here. I'm getting the 6.3 volts input off of pin 4 of the 6AL5, and as you can see, it works great. So no more batteries, and no more worries about corrosion. Now what I can do, I'm going to set it to ohms. There's my ohm scale. Okay, ohms works. We're in good shape. So before I begin calibration, one of the things that I need to do is make sure my test leads are in order. I was just using a pair of test leads I had for another meter. So what I did was went ahead and built a couple of test leads. This is a alligator clip with the little banana insert. This one's my AC probe, and I color coded it to match the socket there so I don't get it confused, which is easy to do. So I still need my DC probe. Now the DC probe's a little different. It's not just a matter of making a test lead. I need to add a 1 meg resistor, which I've got right here, and it has to be near the tip of the probe. So probes you can make from parts you can get online. Here are some ends that insert into the meter. I've got the test lead ends, and then I've got some wire right here. So to make the DC probe, I need to cut 36 inches of wire here. Right there. Right. I tin these ends here. Alright. Alright. This is screw down. Okay, nice and snug. And that takes care of that end. Now these just pop off, some screw on, just one of those that come off relatively easily. So what I need to do now is really need to put one end of this in here. Go ahead and wrap that around. And I'm going to solder that in there. So okay, so I need some strain relief, so what I'm going to do is put some hot glue on here. Should give me the strain relief I need, and it'll keep it from twisting, which could cause some problems later down the line. And there we have a 1 meg probe for DC. Now, one of the things I do need to do is mark this somehow so that I don't get it or use it with other test equipment. Okay. That should work. So, there's my test leads. So the first step in calibrating this thing is actually to turn the thing on and let it sit for a little while. I've had this thing on for about 5 minutes, so it gives it time for the tubes to warm up and for it to stabilize. Now, one of the things that I did on this, now every VTVM is going to be a little different, but on this particular one, all your adjustments are on the side here, and I went ahead and labeled them. I got my AC balance, my DC calibration, and my AC calibration. The AC balance you probably will never have to use unless your tube's going bad, but basically what it is when your tube is, your rectifier tube is going bad, when you start flipping the scales, this needle will move around quite a bit. If it starts doing that, that's because your tube's going out of calibration and eventually will need to be replaced, but that allows you to adjust that. So let's go ahead and take a look at that real quick. I think on this is fine. Yeah, it's not moving at all. If there was a deflection, then I would have to adjust that. And I always use a non-conductive tool for doing any alignments, really. So I know my AC balance is good. The next, and you kind of follow the order here. I have AC balance, DC calibration, AC. I'm going to do the DC calibration next. And what that's going to involve is using a battery. And all I'm going to do is, I have another meter here. It's on DC. I'm going to go ahead and let's see how much this battery is. 1.57 volts. So, knowing that that's 1.57 volts, I need to have 1.57 volts here. So, if I go to my DC scale, let me bring that down to 5 volts. And if I take this battery and see where we're at, it's a little bit low. It's reading about 1.4.5. So I'm going to go ahead and take this on here. Try and get to where I don't have to hold the leads. Yeah, that's not too bad if I can hold them like that. Okay, so I'm going to go ahead and my DC calibration. Get on there, wherever it's at. There it is. Okay, 1.57 should be just a little bit less than that one notch past the 1.5. So there it is. Okay, that's my DC calibration. AC calibration is a little different. I'm going to use, I've got AC power here. Let's switch to AC on my digital multimeter. And let's see where we're at. Okay, reading about 120.8, 121, 121 volts. So I need to go to my AC scale. 0 down. And go there, and I need my AC probe. And I need to set this on 150 volt scale. Okay, so where am I reading? At 150, ooh, I'm reading really low. Reading, bring that up quite a bit. About 120 is right about there. A little sensitive. I'm using this scale down here, RMS. Okay. So that's my AC, DC, and my AC balance. And that's pretty much it. Very simple. So as you can see, installing a battery eliminator into a VTVM is not that difficult. As long as you have a rectifier tube that takes a 6.3 to 7 volt filament voltage, you should be golden. These circuits are all over eBay. Just do a search on VTVM battery eliminator and I'm sure it'll pop up. So definitely consider doing that, because getting rid of that battery and the problems that it can cause makes it well worth the price, believe me. So I hope you enjoyed today's episode. If you did, please hit the like button. If you'd like to see more videos like that, please hit subscribe. In the meantime, happy restorations everybody. Hope to see you next video. Goodbye.